All right, today we're diving into something truly mind-bending. We're looking at the work of biologist Michael Levin, and let me tell you, his research is going to challenge pretty much everything you think you know about life, intelligence, and, well, what it even means to be a creature. So let's start with this question. It sounds like something straight out of a sci-fi movie, right? But this is the exact question Levin's work is forcing us to confront. What happens when your cells are, let's say, set free from the usual blueprint of a body? The answer is honestly more startling than you can probably imagine. So first up, we're going to look at how scientists are literally creating brand new organisms. And the wild part is they're not doing it by editing genes or anything like that. Nope. They're doing it just by rearranging old cells. Okay, so take a look at this. This little thing is a xenobot. It's not an animal, it's not a robot in the way we usually think of one. It's a living, programmable organism made entirely from the skin cells of a frog embryo. But here's the kicker. Its DNA is 100% pure frog. There is zero genetic modification going on here. None. And you might think building one is super complex, but the process is almost shockingly simple. Scientists just gently take some skin cells from a regular frog embryo, pop them into a dish, and that's it. The cells do all the work. They clump together, and within a few days, they organize themselves into something completely new, a xenobot. But this is where it gets really fascinating. What can these xenobots do? Well, they swim around using these tiny little hairs that on a frog would normally be used to move mucus around. They can work together in groups and, get this, they can build copies of themselves. They just go around collecting other loose cells, piling them up, and those piles then become new xenobots. They even turn on genes for hearing, a sense that a frog embryo doesn't even have yet. It's incredible. Okay, so if making a whole new life form from frog cells wasn't strange enough for you, this next step brings the whole concept way, way closer to home. These are anthrobots, and they're built using the exact same principle as the xenobots, but they're made from adult human cells, specifically from the lining of a windpipe. And again, just to be clear, no genetic editing. We're talking about your own cells, just put into a new environment. This number, wow. This just shows you how incredible that transformation is. Once these cells are freed from the body and allowed to build something new, about 9,000 of their genes, that's almost half the human genome, completely change how they operate. In a new context, they find a totally new purpose. They even figured out how to heal damaged neurons when put in a lab dish. So, what on earth is going on here, right? This leads us to Michael Levin's central idea, that intelligence isn't just something that happens in your brain. He thinks it's a fundamental property of all life, and it operates in spaces we don't normally even think about. Think of it this way. Our brains use bioelectric signals, right? They use them to solve problems in 3D space, like finding food or not walking into a wall. Well, Levin argues that groups of cells use a very, very similar bioelectric language to solve problems in a totally different arena, what he calls anatomical morphospace. You can think of that as the space of all possible body shapes. Their goal isn't to find food, it's to build and repair a working body. And you know, this idea isn't totally out of left field. Even the father of computing himself, Alan Turing, was obsessed with this stuff, how organisms get their shape. He saw this deep connection, this symmetry between the logic of building a body and the logic of computation and thought. So what this does is it completely reframes intelligence. It's not some on or off switch that only humans have. It's a vast spectrum, a continuum. It's all just a matter of scale and transformation. And once you start looking, you see bizarre examples of this all over nature. This brings us to Levin's continuity thesis. It sounds fancy, but it's a simple idea. It basically says our default assumption in biology should be that there are no magic lines in the sand where mind or intelligence suddenly appears out of nowhere. The burden of proof should be on the people who claim there's some huge fundamental difference between a single problem-solving cell and a thinking human. It's all just a story of scaling up. I mean, just think about the butterfly for a second. If you teach a caterpillar to avoid something, it will still remember to avoid that thing when it becomes a butterfly. Now, why is that so incredible? Because inside that chrysalis, its brain completely dissolves into goo and is rebuilt from scratch. The memory, its identity, somehow survives a total physical reboot. So, where is that information being stored? And that question brings us to the deepest, most profound mystery of all. If xenobots were never a part of evolution, if there was never a blueprint for them in their DNA, then where did their specific form, their behaviors, actually come from?
Our two usual explanations in biology just don't cut it here. It can't be genetics, right? Because there was never any evolutionary pressure for frog cells to be a good xenobot. That never happened. And it can't just be physics, because while physics explains how particles interact, it doesn't explain specific, goal-directed behaviors like work together to build a copy of yourself.
So if our usual toolkit doesn't work, what else is there? What are these cells tapping into to get their instructions? And this is where Levin's hypothesis gets really speculative, but also really compelling. He proposes that there might be a third source of information out there, a kind of non-physical, almost Platonic space of mathematical and geometric patterns. It's an abstract library of possible solutions and forms that life can learn to tap into and use. He calls this the universe's free lunch. Instead of evolution having to pay the incredibly high price of inventing every complex solution from the ground up over millions of years, it can take a shortcut. It can just evolve the ability to find and use a pattern that already exists in this other space. It gets a huge amount of complexity for a very, very low evolutionary cost. It's a bargain. So, when you pull all of this together, these ideas really force us to reconsider the basic categories we use to make sense of the world. I mean, the line between a living creature and a machine, between a mind and just matter, it starts to get incredibly blurry. And the implications here are just profound. If any collection of cells can start solving problems, is any matter in the universe truly dead? This view suggests that maybe the brain is less of a generator of consciousness and more like an antenna that got really good at tuning into these pre-existing patterns. And maybe, just maybe, our own computer algorithms are accidentally tapping into this exact same space, which is why they sometimes do things we never explicitly program them to do. So all this leaves us with one last massive thought to chew on. If all of our science, our biology, even our computer code, if all of it is just the user interface, the front end for a much deeper, hidden reality of patterns and possibilities, then what exactly is running in the background? Answering that, well, that could change everything.